For number 5, we have continuously compounded interest. And we're missing the value of t for time. So let's look how all these numbers fit into the formula. Here it is for continuously compounded interest. The amount in the bank is the principal times the number e raised to the exponent of the interest rate times the time. And so we have several values from the problem. They told us the amount, they told us the principal. E isn't a variable, it's just a number. And then the interest rate was given. The only thing missing was the t in the exponent. So to get a variable out of the exponent, we're going to need to use logarithms. And we want to get the part with the exponent completely alone before we do the logarithm of both sides. So we need to divide by this number that's multiplied in front here. So I'm going to divide both sides by this value. And when I do it on the left side, I get this result here. So here's my equation. Now to get the variable down from the exponent, we're going to use logarithms. Take the logarithm of both sides. I'm using the natural logarithm here, log base e. And on the right side, it's just a value. You can compute it. Now notice what I typed into Excel to compute it. I did the natural log of my value for F4 here. Because Excel's rounding. If I click up here to get even more decimal spots, you can see this decimal goes on quite a ways. So I could have taken it all the way out there to the 6 to where the zeros start. But I didn't even bother with worrying about rounding. I just used the exact value computed when I did this. And so I took the natural logarithm of F4 and it computes it for me. Now again, this value is rounded. But I'm not going to worry about that. I'm just going to always use the exact value computed in Excel to get my next answer. So going back to the equation, on this side, the logarithm of our value, we get this number result. And on the left side, when you have the logarithm with exponents, you can bring the exponents down to the front and multiply. So this exponents part comes to the front. We're multiplying. The natural log of e is equal to 1, so that part basically cancels out. And so what we're left with is right here. And you just need to divide both sides by 0.063, and we'll be left with t. And then again, I'm not dividing this number by 0.063. I just refer back to the cell where the exact computation is and do F7 divided by 0.063, and I get this result. And round the 2 decimal places, you get 2.00. Number 6, we're going to solve it in a similar manner as number 5. So plug these values into the continuously compounded interest formula. Be sure your time is always in terms of years. So 60 months, divide that by 12, it's 5 years. So plug those values in. The only part missing is the interest rate up in the exponent. So to solve, we need to first divide both sides by this value. And when you do, you get this. And again, we don't want to round to the end. So I put it in here so I can work the formula out, but I'm going to refer to this exact cell when I do further computations. To get the variable out of the exponent, I need to take the natural logarithm of both sides. So I do that here. This is just a value, and I'm doing the natural logarithm of the cell where the exact answer is in. And on this side, it allows me to bring the exponents down to the front. Natural log of e is the value 1, so that part disappears. So we're down to here. And now I'm going to divide by 5. And again, not my rounded value. I'm going to refer back to the cell where the exact value is, divide by 5. And I get this long number. And I can round now because I'm at the very end. I only need 3 decimal places of accuracy. So as a percentage, when you move the decimal over 2 spots, with 3 decimal spots of accuracy, you get this percentage. And that's your value for the interest rate.